Our lesson today is on perimeter and area of similar figures, and really this right here is all you have to remember. It's a short lesson, so here we go. If the scale factor of two similar figures is A over B, or A to B, then we know that that is also the ratio of their perimeters. So if the scale factor is A to B, then the ratio of perimeters is A to B. The ratio of the areas of those two similar figures is A squared to B squared. Got to remember that. So let's see how this plays out in some problems. We have similar trapezoids below here. What is the scale factor? Well, remember what we do? We just pick a set of corresponding sides and we find the ratio. So the scale factor, which I'm going to abbreviate SF, is 6 over 9. And remember, we don't have units there for our scale factor, and that'll simplify to 2/3. So there's the scale factor of the two trapezoids. What's the ratio of the perimeters? Well, the ratio of the perimeters, which I'm going to call P1 to P2, is the same as the scale factor, so 2 to 3. All right, what is the ratio of the areas? All right, well, I know the ratio of the areas, and this is figure 1 and this is figure 2. So the ratio of the areas is the side length that I used up here squared divided by the side length in the second one squared. So it's going to be 2 squared over 3 squared, which is 4 to 9. So there's the ratio of the areas. Remember, the scale factor and the ratio of perimeters is the same. The ratio of the areas will be the side lengths squared, one over the other. Okay, here's another example. The scale factor of two similar parallelograms is 3 to 4. Okay, let's make ourselves a little sketch here. Similar parallelograms, we'll call that 3, and we'll call this 4. Similar parallelograms. The area of the larger one is 96. So 96 is A2. Probably what we're going to want to find is A1. Yeah, what is the area of the smaller parallelogram? Okay, well, we know the scale factor. The scale factor is 3 to 4, and we want to write that as a fraction. Okay, what we want to do now is we want to find the ratio of the areas. So that's A1 over A2. And we know we're going to take this and we're going to square the numerator and denominator. So 3 squared over 4 squared. So that's going to be 9/16. Ratio of the areas is 9/16. Okay, well, what I'm looking for is A1. They told me what A2 is. It's 96. So A1 over A2 is actually A1 over 96. And I just found my ratio of those areas right here. So I'm going to plug that in. So now I've got myself a proportion. And remember when we first started solving proportions, we can change the means or extremes to make ourselves have a smaller number when we solve this. So that's what I'm going to do here. I'm going to switch these two numbers here, these extremes. So what I'm going to have is 16 over 96 equals 9 over A1. And the reason I did that is because 16 goes into 96 6 times. So that makes that a really small fraction over there. And when I cross multiply, I get A1. The area of the first one is 54 square inches. All right. In the problem above, the perimeter of the larger parallelogram is 32. So let me just quickly sketch those back up here. We had 3 and 4, scale factor of 3 to 4. The perimeter of the larger one is 32. What is the perimeter of the smaller parallelogram? Well, let's see here. I know the scale factor is 3 to 4, and I know that's also the ratio of the perimeters. That's P2, P1. So I know that equals P1 over P2. So let's plug in what we know is the perimeter of the second one. That's P1 over 32. And then once again, I think I'll switch my means this time. and I'll put 3 over P1 equals 4 over 32. Because why? Because 4/32 is 1/8, so that makes an easy cross product. 3 over P1 equals 1/8, therefore P1 is 24. 24 inches. All right, that's all there is to it. So what do we have here? A couple of practice problems. Since this is so short, well, actually, you know what? As always, you should pause here and do these and come back and I'll have the solutions for you. All right. The triangles below are similar. What is the scale factor? Well, they give us the areas. The area of the first one is 50. The area of the second is 98. So I set up my ratio. I know that the area of 1 over the area of 2 is 50/98. And when I simplify that, I get 25/49. Okay, so I know to find the scale factor, I have to take the square root of 25 and 49. And when I do that, I get 5/7. So the scale factor is 5/7. What is the ratio of the perimeters? Also the same as the scale factor, so it's also 5/7. All right, what do we have here? Two similar rectangles have areas of 27 and 48. The area of the first one, 27, area of the second, 48. The length of one side of the larger rectangle is 16, so I've marked that right here. What are the dimensions of both rectangles? Okay, so just like I did in the previous problem, I have to use the ratio of these areas to find my scale factor. So when I divide 27 by 48, I get 9/16 when I simplify it. Therefore, to get the scale factor, I have to take the square root of 9 and divide that by the square root of 16, and that gives me 3/4 for my scale factor. Okay, so then I know that this side here is 16 inches, so I labeled the corresponding side in the top rectangle S1. So I set up this proportion. S1 over 16 is 3 over 4, because that's the scale factor. So then I just cross multiplied. I could have switched my extremes, but these were small numbers, so I didn't do that. When I took the cross product, I got 4 times S1 is 48. Therefore, S1 has to be 12. Okay, I could have used the scale factor again to figure out what S2 is, because I know this side right here of this triangle has to be 3, right? Because the base times the height has to be 48. But I also know up here that the base times the height has to be 27. And since I just found out that this is 12, all I had to do to find S2 is divide 27, the area, by S1, which is 12. And then when I simplify that, I get that the side length, that second side length over there, is 9/4 inches. All right, that's it for today, and we'll see you next time.